I said to you it was going to be complex, right? It's going to be this kind of complex. All right. Now, remember, if you think you see what's gone wrong, keep it to yourself. Hold on to your hats. The square root of -1. One of the things we know about square roots is that you can rewrite them without these square root signs. You can use index notation, right? Okay. Do you remember why we can use index notation? Like, how does it work? Why is it that 2, the square root of 2, is equal to 2 to the power of half? Like, did people just decide I would like it to be a half? Or what's the reason? Yeah.
Is it because they're inverses?
Yes, kind of. Kind of. There's a simpler reason to it though that doesn't have to appeal to any fancy language that we've learned. Anyone remember? How did you drive this? Yeah.
Because that equals 2 to the power of 1 squared.
Okay, cool. Yeah, we'll go with that. If I say, just think about your simpler example. Think about your index laws. Okay. So if I go 2 cubed times 2 to the 5, I'm multiplying. So what do I do to the indices? I add them. Very good. 2 to the 8. Okay. So now what you consider is what happens when it's a fraction, right? So if I have 2 to the half times 2 to the half, right? Well, you add them, don't you? So half plus half gives you 1, just 2. So in other words, whatever this number is, when you multiply it by itself, you get 2. And we have a name for that number. It's the square root of 2. So far, so good? So I'm going to rewrite this guy. -1 to the power of a half. So far, so good? So you got to do things like this because you got to question everything, right? All right, now let's go back to U7. Let's go back to U7. Okay. I want us to simplify some fractions. Okay. Let's see how we go. Can you simplify that? What's that equal to? 3 over 5. Can you simplify this?
1 over 3.
That's 1 over 3. Okay. Can you simplify this? That's a half. Good. That's important to me because that's a half. So I can write this, can't I? So far, so good? Question everything.
No.
I'm going to keep going. You have a thing?
Okay.
I don't know. You all agreed. All good. So it's just fractions, guys. Come on, just fractions, right? All right. Now I'm going to keep going. Back to the index laws. If I had something like 3 squared to the power of 3. 3 squared to the power of 3, okay? This is a different thing to this, right? What do I do to these indices? I multiply them. Why do I multiply them?
It's actually 9 cubed rather than 3 squared.
Yeah, okay, all right. So it's 9 cubed, which is actually, I don't know, that's a really big number. Okay. 9 cubed, 729. 729. Okay. You can illustrate it in a simpler way though. Cube just means do it 3 times. Yes? 1 time, 2 times, 3 times. Right? Look, 2 times 3. That's 6. Okay. So if this index law works, I can use it here. Can't I? -1 squared. There's 1 part. Power of 1/4.
No, please stop.
Yes.
Why are you shaking your heads at me? You all agreed here, and then you're like, no, doing something shifty, you know. So far, I think it looks okay. You may disagree. Okay, tell me, everyone, -1 squared. 1.
Yes. Oh no.
The number, that we decided what this meant before, right? This is some number where you multiply it by itself 4 times and you get 1. That sounds to me like it's 1. Right?
Screwing up maths.
If I wanted to, I could go back to here. I could square both sides, and I can get back to this guy. If that wasn't bad enough for you, okay? Right? So fallacy number 3.